Fiber optic cables and data centers are aggressively expanding across the Brazilian landscape, converging heavily on the country's southern tech hubs. This expansion is backed by the Brazilian Artificial Intelligence Plan, or PBIA, authorizing a capital budget of 23 billion reals, roughly 3.9 billion US dollars. The explicit objective of this capital allocation is to transition the nation from passively consuming foreign AI models to actively engineering its own. Brazil already operates the most highly capitalized and structurally mature technology ecosystem in Latin America, making it uniquely positioned to absorb this level of funding. The funding is heavily concentrated on massive physical and digital targets, specifically the construction of a world-class supercomputer and training large language models natively in Portuguese. The PBIA functions as a centralized industrial strategy, leveraging state-backed capital to engineer national technological independence. This strategic push for independent infrastructure is driven by a specific policy objective: AI sovereignty. A nation achieves AI sovereignty when it possesses the complete capacity to develop, regulate, and control AI systems according to its own interests, without relying on foreign platforms. Determining whether 23 billion reals can secure that independence requires mapping the specific flow of capital across the ecosystem. We can trace this capital using the key AI sovereignty enablers, or KASE framework. This 8-part model is designed to evaluate the true resilience and independence of a country's AI ecosystem. Mapping the PBIA's budget against these 8 categories identifies where the state is concentrating its power and where the system remains exposed. The total 23 billion real budget is split into 2 distinct, highly unequal functional halves: immediate impact actions and long-term structural actions. First, 350 million reais are allocated to immediate impact initiatives meant to deploy rapid algorithmic solutions in areas like healthcare, education, and public safety. These immediate actions represent just 1.3% of the total budget, and researchers note several of these projects currently lack confirmed funding sources. This chart visualizes the distribution of the actual strategy. It shows a massive 22.5 billion reais directed strictly toward 54 long-term structural actions. These structural actions are designed to build the permanent foundational capacity required to integrate AI across every major sector of the Brazilian economy. Because this long-term budget contains over 98% of the capital, mapping it against the KASE framework provides the most accurate read on Brazil's true priorities, exposing a highly concentrated industrial policy. When we apply the capital to the framework, the algorithms block immediately dominates. It absorbs 46% of the entire structural budget, totaling 11.3 billion reals. Nearly half of the nation's long-term AI capital is channeled directly into algorithmic governance and software development. The vast majority of this segment is driven by a single 9.1 billion real program titled AI Solutions for NIB Missions. This program is a coordinated effort with the Brazilian Development Bank, designed to align AI development directly with the federal government's broader reindustrialization policy. The explicit target for this block of capital is directly subsidizing at least 500 applied AI projects within the country's industrial sector by 2028. Executing an investment of this magnitude relies heavily on the physical and operational capacity of established industrial corporations to actually absorb and deploy the funds. By weighting the budget heavily toward algorithmic deployment in manufacturing and production, Brazil is prioritizing raw economic output and industrial efficiency over other enablers. To train and run these industrial algorithms, the country requires a massive foundational layer of hardware and raw information. The chart shows the next tier of investment: the computing capacity and data blocks. They receive a combined 40% of the structural budget, split evenly. The cornerstone of computing capacity is a 1.8 billion real physical upgrade to the Santos Dumont supercomputer. The strategic objective is to push the Santos Dumont system into the top 5 globally for computational capacity by 2027. Shifting to the data block, the government is allocating 1 billion reals to build a secure, non-public cloud specifically for confidential state documents. Another 1.1 billion reals in this category is assigned to organizing and curating national datasets, which will be used to train natural language processing models strictly in Brazilian Portuguese. Taken together, these infrastructure investments are designed to physically isolate Brazilian state data and permanently sever the country's reliance on foreign data centers and proprietary language models. While the core enablers are heavily capitalized, the fringes of the KASE framework tell a different story, beginning with electricity. Electricity receives only 2% of the structural budget, totaling roughly 500 million reals. This low allocation is a geographic advantage. Brazil operates with a massive surplus of renewable energy, negating the need to heavily subsidize basic power generation. But that geographic advantage contrasts sharply with a severe systemic flaw. The cybersecurity block receives less than 1% of the total budget, at just 185 million reals. The capital mapping reveals a distinct paradox. Brazil is financing top-tier supercomputers and secure government cloud networks, but allocating virtually no capital to defend them from intrusion. This severe lack of funding contradicts global defense trends and directly undermines the framework laid out in Brazil's own 2023 National Cybersecurity Policy. An 11.3 billion real algorithmic engine stops being an asset and becomes a massive liability if it lacks the protective armor required to secure it from state and non-state threats. Beyond the state capital allocations, there is a final external variable that will govern this entire 23 billion real infrastructure: Brazil's impending regulatory architecture. This architecture is anchored by Bill 2338, a comprehensive legal framework designed to establish strict risk classifications and transparency obligations for the use of artificial intelligence. The bill was originally introduced by the President of the Senate, Rodrigo Pacheco. A substitute text was approved by the Senate in late 2024, and the legislation is currently undergoing review in the Chamber of Deputies. As the state aggressively injects capital to build the AI sector, this impending legislation will simultaneously generate significant new legal and financial compliance costs for developers. Without careful alignment between the state's financial strategy and its legal code, the heavy cost of regulatory compliance could stifle the exact technological boom the PBIA is trying to engineer. This poses a specific threat to the ecosystem at large. Massive industrial corporations can absorb new compliance costs with relative ease, but smaller innovators and startups risk being priced out of the market entirely. To prevent consolidation, policy analysts suggest the state must synchronize its infrastructure spending with the creation of regulatory sandboxes. These enclosed environments allow startups to rigorously test their AI models without facing immediate legal sanctions or crippling fines. The PBIA's extreme capital concentration in compute hardware and algorithmic development provides Brazil with the raw physical capacity required for AI sovereignty. However, long-term technological independence will ultimately fail unless the state closes its glaring cybersecurity gap and calibrates its regulations to protect the entire ecosystem, not just its industrial giants.